All right, I'm going to go share my screen and we're going to do homework problems from Mathematical Reasoning, Chapter 2, A, B, and C. So here we go. I'm going to share my screen. All right, so my first problem, my paper here. What does the word of mean? What does of mean? Y'all, of means to multiply by. Like if you want a third of a piece of cake, you would multiply to 1/3 times the piece of cake. And then remember this one too. I didn't ask it here, but per, P-E-R, means to divide by. Okay, divide by and for per and multiply by for of. Two little words that mean a lot. All right, now this one wants to know how much would a person pay for 9.5 pounds of bananas, 9.5 pounds of bananas at a price for the bananas of $1.67 per pound. So 9.5 pounds of bananas at 1.67 pounds. So what you would do, we're going to take this 9.5 pounds of bananas and we're going to set up our unit conversions. Now here they're giving me a conversion because they're telling me it's $1.67 per pound. And remember, per means to divide by the pounds. So to cancel these pounds, I would take these pounds. So remember, this is like 1.67 dollars per pound. So that's what we put here. 1.67 per pound. Let's see how the pounds are on bottom. These pounds are on top. You need one on top and one on bottom so that they'll cancel. Now we'll be left with how many pounds we bought at the price per pound we pay. So when the pounds cancel, we end up with the money, and that's what we need since we're talking about how much we're going to pay. So I'm going to multiply that on the calculator, 9.5 times 1.67. So everything on top gets multiplied together. Whoops, told me I had an error. Whoops, that should have been a point. So 9.5 times 1.67 would give me 15.865. And if I want to round to the nearest cent, that would be $15.87. So round up to a 7 since that was a 5 there, okay? So that's how much I'd pay in the long run for my 9.5 pounds of bananas. All right, check this out. A person is paid $490 for 22 hours of work. So $490 for 22 hours of work. What is his hourly pay? Okay, so what we would do, hourly would pay would be how much money per hour, right? So we're going to take that 490, set it up. Now, all we know is that he made $490 and he had 22 hours of work. So that was for 22 hours of work, right? So y'all get that set up. Let's see what we're gonna do here. Lost my problem. Okay, there we go, right? So now we got money over hours. Y'all with me? So now once we figure that out, that's going to give me how much money he makes per hour. Okay? How much you make per hour, since that's our hourly pay. So now what I did, I took that $4.90 and divided by the 22 hours, and that gave me 22 point, I went around to the nearest cents, so that would be 27. Yeah, because the number after the 7 is a 2, so I'm not going to round that one up. I'm going to leave it a 7. Um, oh yeah, and then the units on that would be what? Dollars per hour. I was trying to see if they made y'all put the units, and they actually make you pick one. It's not hours, because that's not canceled. It's not dollars, because we didn't cancel the dollars. So what we were left with was actually dollars per hour, since we didn't cancel no units. So y'all do have to put a choice on that, okay? All right, so this one wants to know, what is the total cost of 1.9 cubic yards? Now remember, cubic yards is a YD with an exponent of 3 by it, of soil. So 1.9 cubic yards of soil, if the soil sells for $31 per cubic yard. Okay, so we want 1.9 cubic yards of soil, and it's going to cost us $31 per cubic yard. So since we're looking for our total cost, when we're done, we should only end up with the money and not the yards, okay? So y'all watch what I'm going to do. 1.9 cubic yards. Now my conversion factor over here is $31 per yard cubed. So that would be like $31 over your yards cubed. But remember, over here, since we're technically dividing by this fraction, we would flip it and multiply, because we need these yard cubes down here to be down on the bottom, and the 31 to be on the top. So this one pretty much came in just like it looked, right? The yards were on the bottom, money on the top. It's just you got to remember when you have it written like that, that per means you're really dividing, okay? And it don't matter what they look like over here. You arrange them over here so that these units cancel with what you already got. So these yards cancel, and I'm going to be left with money. So this one I would do 1.9 times 31, and that gives me a price of 58.9, which will be $58.90. And they just say type a integer or decimal, so you might not even have to put the 0 on that answer. You might just put 58.9 and it would take that, okay? And this is my number 5. So Sid needs 0.6 meters of canvas material to make a carry-all bag for his wheelchair. The canvas is 723 per meter. How much will Sid spend? Okay, so we know this is my conversion meter over here, and this is what he wants. So I'm going to have my 0.6 meters. And my conversion is over here, $7.23 per, which means divided, meter. So that's going to come over here this way it looks, 7.23 per meter. And then y'all look at that, the meters will cancel, so I'm going to be left with my money. So let's see what 0.6 times 7.23 gives us. And that's going to give me 4 point, let's see how they want me to round to the nearest cent. So that's going to be a 3. And then since that 3 has an 8 behind it, I'm going to round that 3 to a 4. All right, check this out. If your car gets 30 miles per gallon, how much does it cost to drive 350 miles when gasoline is $2.90 per mile? So you get 30 miles per gallon with your car. You're driving 350 miles and your gas is $2.90 per mile. So we're looking for a price when we're done with this, right? So let's see what we got. We're going to start with our distance because our distance don't have a conversion. It's just what? 350 miles. So let's start getting us some conversions going so that we can get stuff to cancel. So check this out. I know that my car gets 30 miles per gallon, so I can get the miles. Remember, that's like 30 miles divided by gallon. But this time I want the miles to cancel, so I want the 30 miles to be on the bottom and the gallon on top. Okay? Remember, you can arrange these either way you need to over here in order to cancel out your units. You just got to have it. 1 gallon is 30 miles, or 30 miles is a gallon of gas. So look what happened. The miles have canceled so far. Now, right here, oops, this ain't 290 per mile. This is what, 290 per gallon. Y'all can't let me do that, okay? Got to keep me straight. So $2.90 per gallon when you get gas, right? Because I need that gallon to cancel this gallon. So I'm going to come over here and put $2.90 per gallon. Notice my gallons will now cancel. And I'll be left with my money, which is what I need. So I'm going to be left with how much money it's going to be. So what you do, everything on top gets multiplied. So 350 times 290 is going to give me 1,015. And everything on top after you multiply gets divided by everything on the bottom. And really all I got on bottom is 30. So I'm going to divide that answer by 30. And I get 33.8, and rounding that would be to a 3 because after it is a 3, and that'll be $33.83 I'll spend for my trip going 350 miles in this car that gets 30 miles per gallon, paying $2.90 per gallon. So, y'all, this stuff is fun once you get to figuring them out, right? All right, this one wants me to convert 6 feet to inches. And y'all know that conversion. 1 foot equals 12 inches. So we're starting with 6 feet. And let's start this out. And our only conversion is feet to inches. So for 1 foot, it's 12 inches. So notice These feet are going to cancel. You're going to be left with inches, which is what they want. So since these are both on top, you're going to multiply 6 times 12. That's going to give me 72 inches, since inches was what unit was left. All right, 8, we're going to convert 18 minutes to seconds. So I know that conversion from minutes and seconds is 1 minute equals 60 seconds. So we're starting with 18 minutes. And remember, I need to put this so that these minutes will cancel. So I'm going to put my 1 minute down here. And 1 minute equals 60 seconds. So check this out. The minutes cancel. I'll be left with seconds for my answer. And all I got to do is multiply 18 times 60. And that's going to give me a pretty big number, what? 1,080. So 1,080 seconds is how many seconds is in 18 minutes. That makes sense. 60, 60, 60. You do that about 18 times, I'm sure you'll get there, right? All right, y'all, what are we on, number 9? Convert 6 years to hours. Alrighty, so let me see. I'm going to have to do this in a few ways. I'm going to have to get from hours to years, or years to hours. Now, I know I'll go from days. How about this? 1 day equals 24 hours. Now I can go from days to years, because 1 year is what? 352 days. I think it's 352. If it ain't, I'm a little off, right? So, and let's see, that's going to get me from days to years. And then I got my days and hours. Okay, that's all I need. So I got 6 years I'm starting with. So that's my given amount, right? I'm going to go from years to days. So for every year, there's 352 days. So watch this. The years cancel. Now I can go from my days to my hours, because for every 1 day, there's 24 hours. So that does it, right? My days cancel. I'm left with hours like they wanted. So since all these are on top, we're going to multiply 6 times 352 times 24 is going to give me 50,688 hours. All right, so let me see. That was my number 9. Let me just make sure. I got 52,560. So what is it? A little bit more days a year. I ain't got my how many days is in a year, but I got a chart with that on it somewhere, y'all. Let me look. Oh, that ain't got it on it either. Oh well. 356, 360. Who knows? 365 days, ain't it? I bet it's 365, I think. Let's try that. 6 times 365 times 24. 52,560. That's it. Y'all letting me go. 365 days. So that this would actually be 52,560 hours. Ooh, I had a brain freeze there for a second. My bad. All right, check this one out. You return from a trip with 120 British euros. I mean, that's British pounds, it says. Okay, I'm used to them being euros. That's pounds. So you got 120 British pounds. How many US dollars is that worth? So we want to be able to convert pounds to US dollars, and they got a conversion for British pounds to US dollars. And that conversion is 0.5656. So to go from pounds to dollars, you're going to multiply by 0.5656. Now, from dollars to pounds, their conversion would be 1.768, but we don't need to know that on this. In the homework, they give you a chart with both of them on here. It'll say British pound, US dollars per British pound, and British pounds per US dollar. Okay. All right, so let me put my other one on there, which was US dollars per British pound. And that conversion was 1.768. Right, y'all, so let me get my pages right. All right, so let me see. Now, what was I asking? I had 120 British pounds, and I want to know how many US dollars is that worth, okay? So I want to know how much is my US dollars per British pound. So watch this. I'm going to start with my 120 British pounds. So I'm just going to use a little shorthand here for pounds. Okay. So they told me the conversion for British pounds to US dollars is 1.768 US dollars for every British pounds. Now, if you had dollars and wanted to go to pounds, you would use this one up here where you canceled out the dollars and you had the 0.0565 with the British pounds on top, okay? So you got to be careful. Which way am I going? So let's see what that gives us. 120 times 1.768 should give me what, about $212.16. So that's not bad, right? I get 212 out of 120 British pounds. All right, next they want me to evaluate the following expressions. So number 11, evaluate A has 10 to the 8th times 10 to the 7th. B has 10 to the 9th times 10 to the negative 5th. C has 10 to the 9th over 10 to the 3rd. And D has 10 to the 12th over 10 to the negative 4th. So watch what I do on these. These are exponent rules, okay? So anytime you're multiplying two numbers that are the same, you're going to take these exponents and add them together. So 10 to the 8th times 10 to the 7th. The first step is take the 10 and then add the exponents, 8 plus 7. So your final answer will be 10 to the 15th. Think about it. You had 8 tens here, being multiplied. You got 7 tens here being multiplied. All together, you got 15 tens being multiplied. And that's all these exponents mean is 10 times 10 times 10 times this 7 tens, okay? All right, B is 10 to the 9th times 10 to the negative 5th. Same thing, they both have a 10, so bring down to 10. And then you're going to add the exponents, 9 plus negative 5. So then you bring down to 10. 9 plus a negative 5. Anytime you add unlike signs, you subtract the numbers. 9 minus 5 is 4. And then the answer has whatever sign the bigger number had. So since this 9 is positive, that 4 is positive. C, I had 10 to the 9th over 10 to the 3rd. Now, when you multiplied stuff with the same numbers, you added exponents. When you divide stuff with the same numbers, you're going to subtract exponents. So this will be like 10 to the 9 minus 3. Well, bring down to 10, and 9 minus 3 is 6. That makes sense because this is 10 wrote 9 times. On the bottom is 10 wrote 3 times, and 3 of those would cancel out, leaving the 6. All right, D is 10 to the 12th over 10 to the negative 4th. Now remember, on these exponents, you got to take the top minus the bottom. So this will be 10, because they both match, 12 minus negative 4. So you got a negative on bottom, so when you subtract the top minus the bottom, you're going to be subtracting a negative number. But remember, anytime you're in math and you subtract a negative, you turn that to a positive. So this is like 12 plus 4, which gives me 10 to the 16th. Okay? All right, moving on. Let me turn my pages, y'all. Number 12, I'll do that one. So this one says a certain race is a distance of 28 furlongs. How far is the race in miles? So they want to know how many miles that is. And then B, how many yards that is. So I got a little measurement down here. And if you notice, 1 furlong is 1/8 of a mile. So that'll be pretty much what I use on the first one for miles. And then I can convert my miles into yards with this conversion. So let's see what we got. 1 furlong equals 1/8 of a mile. And if you want that as decimal, 1 divided by 8, that's going to give you 0.125 of a mile. That's 1/8 of a mile. Or you can leave it in the fraction form. And then the next conversion I wanted was that 1 mile equaled 1,760 yards. Okay, that's all I needed on this, right? Miles and yards. So for A, I'm going to take my 28 furlongs. So we're just going to shorthand that fur. And over here it said 1 furlong. So for every furlong, it is 0.125 of a mile, right? Alrighty, so for this one, I'm going to cancel my furlongs, and I got my answer. So that'll be 28 times 0.125. And y'all, let's see, what am I getting? 3.5 on number 12. And that'll be in miles. Okay. Now, it wants me to turn these furlongs into yards. But since I turned furlongs into miles, I can now take these 3.5 miles, and for part B, turn these 3.5 miles into yards, because I know for every mile it is 1,760 yards. So watch this, I can cancel my miles. So this, you could do all this in one big step again, but if you've already got one unit knocked out and you got a conversion using that unit, might as well do it, right? So 3.5 times 1760 is going to give me 6160 yards. Okay, so let's see, what we got next? Let's see. Okay, 13 is one of those where you got to figure out the prices better. So I can buy shampoo, 6-ounce bottle of shampoo is $3.59. 14-ounce bottle, $11.49. Which is better? So which is better? So really on this, you're going to take the price, divide by the ounces so that you'll have the dollars per ounce. Then you'll take this one's price, divide by the ounces, so you'll have the dollars per ounce. If we can get the dollars per ounce, we can see which one is the better deal. So I'm going to start with my 359 over 6 ounces. So let's see what we get. 3.59 divided by 6 is going to give me, oh, I'm going to call that 0.598. I'm going to round that to a 0.60, right? About 60 cents. Now let's try this one. 11.49 divided by 14 ounces. So 11.49 divided by 14. That's giving me 0.82. So what am I doing? 13. Let me find the rest of my question, y'all. Oh, y'all, so what did we come up with on a better deal? So that's what they want on part A. Which one was the better deal? And better deal would be my choice. 6-ounce bottle is better deal. And y'all, that's because I'm only paying 60 cents per ounce instead of 82 cents per ounce. I'm paying 22 cents higher for that one, okay? All right, so that's the main thing on that one, was just to find that price per ounce and then see which one was better. All right, so I'm going to skip around so you're getting the idea on some of those. So let me skip around. Let's see. Oh, okay, here's a good one. This is like number 16 for y'all. Which statement best describes a temperature of 110 degrees Celsius? So let me give y'all some information on Celsius. In the Celsius temperatures, water freezes at 0 degrees Celsius. That is the same as 32 degrees Fahrenheit. Okay. In the Celsius temperatures, 100 degrees Celsius is boiling. That's the same as 212 degrees Fahrenheit. So check out so knowing that, here's my 110. So it is higher than 100, which means it's a little bit higher than boiling water. So check out these choices. So it's typical of Antarctica in the winter, since Antarctica gets very cold. No, no, not that one, right? It's typical of Phoenix in the summer, since 110 is very hot and Phoenix gets very hot during the summer. Well, y'all, 110 is very hot, but it's a little bit hotter than Phoenix is going to get, right? It's hot enough to boil water, since 110 is above the boiling point of water. And remember, I showed you my scale over here. 110, 100 is boiling, and you're sitting down here at 110 Celsius. So we would go with the choice C on that one. Okay. It is hotter than boiling water. All right, so I'm going to skip and do 18 because 18 is a tricky one. They're telling me, suppose 8 turns of wire wrap around a pipe with a length of 60 inches. So my pipe is 60 inches long, and it has a circumference of 4 centimeters. Nope, 4 inches. They're keeping everything inches. So it's 60 inches long, 4 inches around. That's what the circumference is how round it is. So that the wire reaches from the bottom of the pipe to the top. So what they do, y'all, they got this pipe laying here, okay? So here's me a pipe. They took this wire and they wrapped it around the pipe like that 8 times. So I don't have exactly 8 times, but that wire wrapped around 8 times, okay? So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's my wire wrapped around my pipe. They want to know, how long is the wire? What is the length of that wire? Now they give you a clue. They say, hey, cut this out and lay it flat. So if you did that, watch what you're going to get. You got your ends of your pipe, and you're going to have 8. So let me draw this right. So the wire's wrapping around, wrapping around, wrapping around. Okay. I had that drawn over here. I want y'all to get the idea of what we got going on. So if you did that right, it would be 8 of these diagonals going down through here. So I'm trying to draw them. Now, just imagine there's 8 of those, okay? But notice, if I draw little lines like that, each one of these makes little triangles. Now check this out. I knew this side was 60 inches long, and I now know this is 4 inches wide because that was my circumference. And if I cut it open, what I'm looking for is how long are these diagonals going down like that. So there was 8 of those diagonals. So to get the length of each one of these little triangles, I'm going to do 60 divided by, let me turn this on, 60 divided by 8. You have 60 inches and you had 8 turns of wire. So 60 divided by 8 gave me 7.5 inches for each one of these little triangles on this side. Now I know this side on each one of them is 4 because they told me that's what that circumference was. So we need to find this distance. And y'all, we got a friend called the Pythagorean theorem that we use to solve those. C is your hypotenuse, which is these longest sides of our triangles. This is A and this is B. Now to solve this C squared, you would have C equals the square root of the A squared plus the B squared. So when you're doing this, you're going to have the same formula I am. The only difference might be the circumference or how long your pole is. If your pole's 80, you'll do 80 divided by 8 as long as it's 8 turns, okay? So this is the number of turns, and this is the length of that pole for y'all, okay? So now this would be the square root of 4 squared plus 7.5 squared. Now, if you're doing this on order of operations by hand, you would square those numbers first before you did the square root. So let's bring that over here. So 4 squared would be 16 plus 7.5 squared would be 7.5 times 7.5, which would be 56.25. Then before you square root, add them together. So add that to the 16. You get 72.25. At that point, you would take the square root. So second square root, 72.25. Hit enter, and you get about 8.5 per piece of wire. But remember, we only found this piece of wire. I had 8 of those, right? So you would finally take the 8.5, multiply that times 8, because I really found just one turn doing that, right? You had 8 of those, so 8.5 times 8 will give me a length of 68 inches for my wire. Whoops, y'all, let me move that up. So what I did, I got my 8.5. That was just one wire. I said I had 8 of those. So I multiplied that 8.5 times 8, because that's each turn I'm going around that pole, right? And that gave me a final length of 68 inches. So those are fun. You just gotta sometimes, that's why they was giving you that little clue in there. So I messed up on that and trying to draw that. So, well, okay, I had to cut it open and figure out what we was doing. We was doing triangles on it, okay? Oh, and I like this last one I'm going to do is this number 19. Check this out. You're considering buying 12 gold coins. Okay? I'm going to buy 12 gold coins. And they all look alike. But you have been told that one of them is a heavy counterfeit. So one is heavy counterfeit. So it must weigh more than the other ones, okay? So, but the counterfeit probably what watch this what I do. The question here is how can you find the heavy counterfeit coin or the heavy coin in 3 weighings on a balance scale? So check this out. I got 12 coins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So watch what I'm going to do. I'm going to do 3 weighings, okay? So I got 12 of these, and I need to do it. So, like if I did 6 and 6 on the scale, that would tell me if 6 of them were equal to other 6, but we know we couldn't do that because one of these would be false, so there's no way that would help me at all. Because I know for sure if I did all of them in 6 and 6, one would have to be false. I can't do them one by one because I'd never get done in 3 weighings. So y'all, what I'm going to do on my first weighing I'm going to do those 4 and those 4. I'm going to do 4 on one side and 4 on the other side of the scale. Because guess what? If they equally weigh the same, then I know there's not a heavy coin in those, right? And then if one of these is heavier than the other, then I will keep the heavier set of coins and throw all the others into my good coin pile because they're all eliminated because I found a pile that weighed more than another pile. And then what I would do, I would take 2 and 2. I would put 2 coins on each side. The heavy side would have to weigh more than the light side. So at that point, that would leave me with 2 coins. And on my third scale, I would do those 2 coins and know which one was heavy. Now, suppose these 2 were equal. If these 2 were equal, then I'm still going to get this done in 3 things, because if these 2 are equal, that means none of them are heavy, and I would be left with them 4 coins, which means that same scenario as before. Out of these 4, for my second one, I would do 2 and 2. I would know one of these was heavy, so say this one was my heavier one, and on my third one, I would do 1 and 1, and I would isolate my heavy coin. So did you see how we did that? 2 methods. I did 4 and 4. That way, if one of these was heavy, I eliminated everybody else and focused on them. If these were equal, I knew they was all good, so I eliminated all them and focused on these because the heavy one had to be in these 4. And then we just break it down, y'all. Once you got 4 out of either method, 4 turns into 2, and those 2 turned into 1 on that last reading. All right, so I'm going to quit my share on that. I just wanted to give you an idea of how to do some of those homework problems. You got to sort of think on these things, okay?